Hi, this green crystal is quite pretty, but actually its value isn't in its appearance. This mineral is called monazite. This particular example is from Madagascar. This mineral is valuable, and it's valuable because of its composition. Now, the main type, or the most common type of monazite, has a chemical composition like this, but it can vary with all these different elements in it. It's a phosphate mineral. That's not what makes it valuable, though. If you look at all those other elements that are listed there, these are elements that we find down the bottom of the periodic table, what we call the rare earth elements. Now, the rare earth elements are found in lots of different rocks, but generally in tiny quantities. Yet, as we're going to see, these things are incredibly useful, particularly in modern electronics. What I want us to do today is to think about how many of these different elements that we need to make a modern electronic device that we almost take for granted. Because I want us to look at the geology of a smartphone. Now, a smartphone is a remarkable thing. The technology that gives us such a powerful computer in our pockets, that enables us to access the web, play games, communicate with people in all sorts of different ways, to be able to pay for things, to be able to, I suppose, interact with the wider world, is actually made up of a collection of elements. Now, as geologists, we know that these elements can only really come from rocks in the ground. We'll look at the rocks where these come from in a later lesson. But let's just think, first of all, of this range of elements. You can see from this diagram that different parts of the smartphone, the case, the battery, the screen, the electronics, use a wide variety of different elements, some of them perhaps quite surprising. You may be surprised to see the mixture of these rare earth elements that are used to produce the different colours on the screen on the phone, as well as the elements that are used to conduct electricity or to make the glass. The electronics that drive the machine are an even wider range of different metals and other elements within the periodic table. I want us to look at how much of the periodic table we actually use. In your booklets, you'll find a simplified version of this diagram. This shows us the elements that go into the different parts of a smartphone. What I'd like you to do is I'd like to use this information to show which elements on the periodic table you carry around in your pocket. You have a copy of the periodic table. You're probably familiar with this from posters on the wall in the chemistry lab. We need to amend it slightly though. We're geologists. We only really concern ourselves with elements that occur naturally on Earth. So let's get rid of technetium and this sort of range of exotic human-generated elements down at the bottom. Those are the 93 elements that occur naturally on Earth. That's the composition of the Earth. That's what the Earth is made of. What I'd like you to do is I'd like you to go through that diagram and I'd like you to highlight all of the elements that are used to make a smartphone. Once you've done that, can you work out the proportion, the percentage of the periodic table that you're actually carrying around in your pocket? So, press pause now and have a go at that task. Okay, let's see what we've got. This is our periodic table. We've already deleted off the non-natural elements, and we're left with our 93. If we highlight the ones that we can find in a smartphone, we should see something like this. You can see from your own diagrams, that's an awful lot. Over half of the periodic table, half of the total elements that there are used to make a smartphone. Now, each of these minerals doesn't occur in the same quantity within the Earth. There are varying amounts of each of these. If we look at another version of this periodic table, this indicates this difference between the amount of elements that there are, the amount of elements that we can find within the Earth, and our demand for them. The minerals you can see here highlighted in red are under serious threat of us running out within the next 100 years. The ones in orange, we are concerned about their potential shortages in the future. The ones in yellow may well have a risk to future supply. Only the ones in green have we got more than enough for what we need. So you can see that finding new sources of these metals is going to be critical over the next few years. Recycling may not be the answer. Certainly as we increasingly change our energy source to electricity, we increasingly use electronics in our lives, the amount of material that we're going to need to make those is going to increase. And remember, these are elements. They can't be made. They can't be created We can only go and find what the geology has given us. There are some extra videos to look at on what each of these minerals do and their future sustainability. They're worth a watch if you have time. So, those of you that dug deeper, we saw how much of the periodic table is in a smartphone. You've highlighted that. There are about 54 different elements in a smartphone. Now, out of 93 naturally occurring ones, that's 58% of the periodic table that's needed to make a smartphone. And remember, that's to make it work. It's not just to make it pretty. These minerals, these elements are essential. So, to conclude, all of these elements that are required need to be found as minerals in rocks in the ground. The people who are going to go and find those and get them out, hopefully in a sustainable way, are going to be geologists. But to do that, we need to learn the skills to identify these minerals and to know how to find them. Many of these are really not easy to find at all. But that's for another lesson. I'll see you then.